Thank you, everybody, for joining us for the Mesmer Research Group guest speaker series this week. We have Dr. Eric Specking from the University of Arkansas, and he'll be discussing system design and analytics laboratory at the University of Arkansas. So take it away, Eric.
Well, one, I just want to again thank you for inviting me to speak. It's an honor to come and talk to you all about what our team's doing. And yeah, the topic today, it's not just my specific research and interest. It's all about our whole lab. So I'm part of the University of Arkansas System Design and Analytics Laboratory, which is part of our industrial engineering department. And to kind of what we like to do in our lab is we like to use what's called bottom lines up fronts. And so for those who are not familiar, it's basically you're going to see this 3 times. You're going to get to see some of the key content, and then you're going to get to see these same images again at different times throughout the presentation, but then this will also be my summary slide. So that way it helps you see some of the key things multiple times. But the bottom line up front is we're going to talk a little bit about the vision of our lab, which is basically trying to help research sponsors, add as most value as they can. I'm going to talk a little bit about our team and our key research areas, and then some of the techniques that we've kind of built off of and like to use in our work, like integrated modeling and set-based design. And then I'm going to not end because it's a large part of the presentation, run through several past project examples. I am going to do this pretty quickly since I know that you want to have time for Q&A. So I'm going to keep it really at high level on all of the examples, but there are papers that's already been published about most of them, and we can always go in depth later on. So to jump in, our lab, basically, like I said, we're not a typical research group that's all about trying to do fundamental research. Most of our projects is finding some type of organization, whether it's a government organization or an industry partner who has a need. And then we use our expertise to help them add value. And so really it's using system engineering, decision and risk analysis, and trade-off analytics methods to help them identify promising opportunities to create high-value solutions with acceptable risks. Now, our team started officially in 2016, or the name of this lab. And since we've had a lot of graduates as well as new team members coming out, and we do try to get as diverse group as possible. And we have a mix of undergraduate researchers as well as PhD and graduate or master students, as you can see here. And of course, Dr. Gregory Purnell and Dr. Edward Pohl are the directors of this lab. But to point out some other key people, we have 5 faculty, and then we bring in some visiting. So Dr. Islamov, he was a visiting professor from Turkestan this year, and that was a lot of fun. Then we had a visiting PhD student, Daniel Manzo, who is a lieutenant colonel in the Brazilian Air Force. And so this has really helped us expand our horizons and get different trains of thought to add additional value to what we're doing. So we focus really in these areas: decision analysis, risk analysis, trade-off analytics, systems engineering, set-based design, cost analysis, and using agile software development. And so you can look at it that these research areas are where we pull our tools and methods from. And of course, the agile software development, what we like to do for clients is try to get to a minimum viable product as soon as possible that, gets something out in front of them really quickly to help them understand the direction we're going, and then use agile development to improve and get to the finished product over the timeline of the project. So a lot of the application areas that we've worked in is along defense, homeland security, transportation, finance, environmental, engineered resilient systems, and smart bases. Of course, the education that we teach our students aligned with the research focus, which is around decision analysis, system engineering, and risk analysis. And we do feel like we've been pretty successful. We have several publications that's happened over the last, since the lab started, in well-known journals from systems engineering to decision analysis, the IEEE Transactions of Engineering Management, of course, the Engineering Management Journal, Applied Sciences, and others are. We've gotten some book chapters as well as books. So Dr. Purnell is the lead editor, author on several decision making and decision analysis, system engineering, trade-off analytics type of books over the years as well. Now, where research usually takes in a lot of ours, you can look at it in like 3 phases, right? So you can be in the areas that's trying to identify certain opportunities and, try to look for those root cause of problems, right? So the problem solving stages, and that really helps you identify the decision opportunities. Well, once you have those decision opportunities identified, then you can develop tools and techniques to develop good decisions. From those good decisions, you then can get and convert those good decisions into implementation, so solutions, right? Most of our work is in stage 2 and stage 3. This slide actually was developed from one of our visiting students. So Daniel, who just left us from Brazil, and his research was more in stage 1. But everything I'm going to talk to you today is about stage 2 and stage 3, because that's where most of our work occurs. And to get into some of our tools, the first one is integrated modeling. And so what we found that if we use integrated models with Monte Carlo simulation, we're able to increase and create value and reduce risk for our clients. And really, it's helping take advantage of model-based engineering and other digital engineering artifacts with different analytics. And so what we like to do is create influence diagrams. And if you're not familiar with influence diagrams, basically it's not a flow chart, but it's a diagram that shows the flow of information. So all the arrows show flow of information or a probabilistic relationship. And we create our models this way, and we align it with descriptive, predictive, and prescriptive analytics to show those connections. And when you do that, what you're able to do is then start creating your models to be able to connect those and interface those different models together, so you have this one big integrated framework for all your model simulations and analyses. And the benefit, of course, is that it allows you to say you have a change in system functions or a change in the requirements or design decisions. It will trickle through the entire integrated model. So through all the other models and simulations, and you can see how those changes affect your end values, which what we like to do, especially if we use multiple objective decision analysis to define value and separate costs, we can look at affordability and show at how much does a certain value cost, right? And so that gets into that trade-off analysis. Another tool or technique that we've developed is set-based design, and it's not something we came up with. Toyota's been doing it for 40 years or so, but they've never really told what their secret sauce is, right? And so what we have done is, and I'll go more in depth in a little bit later, is that we use set-based design because what we found, instead of just creating a point design for, especially when you're doing an analysis of alternatives, you're able to increase the likelihood that you select a feasible, resilient, and affordable design. So the big things, the big 4 qualities of set-based design is: 1, you consider a large number of designs; 2, you allow specialists to consider a design from their own perspective and use the intersection between those individual sets to optimize the design; 3, you want to establish feasibility before you commit to a design or a design decision; and then 4, the whole process should be a concurrent engineering process to provide improved stakeholder value through extensive uncertainty resolution and improved alternative design. And so basically you can see that with this figure here throughout the design process, the life cycle of a design, exploratory concept development through production. You start with a large number of designs and you put those in sets. And so you start classifying them by like things. And that's what makes the sets. But then you get different sets, but the things that makes them different. And then while you go through improving the design using, either models, simulations, prototypes, whatever you need with analysis. You're getting more information about it and getting better uncertainty resolution. So when you get to that point decision, the one that you want to take towards production, you have a higher probability because you've done all this other work that it will remain feasible. It will be resilient to some changes, and it's going to be affordable based off of your analysis, of course. And by using integrated models and set-based design, what we have found are these five big things. And it's really implications for engineering managers, program managers, and analysts. And that's one, using this integrated performance cost schedule with analytics, we've found that it's a best practice for digital engineering and for model-based engineering, especially because for complex system, it's going to enable a greater trade space exploration. Two, we found that when you consider low resolution designs and models, you're going to find that in early design, the Pareto optimality that you find doesn't always guarantee feasibility or achievement of system requirements. Of course, as you increase the resolution of the designs and models, that does help you get to a closer guarantee. You can't always completely 100% guarantee, right? But it does move towards feasibility or closer to that uncertainty resolution. Three, set-based design does prevent premature design decisions from either being selected or eliminated, which helps mitigate program risk. Next, we found integrated models for complex systems with quantitative set-based design really helps inform design maturity for those design decisions, as well as help reduce uncertainty. And then finally, we found that quantitative set-based design deliberately preserves design options until uncertainty is reduced. And what that does, it basically provides program flexibility to help the program achieve performance costs and schedule objectives. So those are the big things that we found over the years by using integrated models and set-based design. So now I'm going to do a few examples of some of our past projects. And I'm going to start with, since I've been really talking a lot about set-based design, I'm going to start with more of the research that we've done related to set-based design. And how we started was, of course, with a literature review, but where it really started for us was we were working with a client on trying to help produce more resilient designs of systems, right? Especially in the early life cycle and engineered systems. So not just any resilient system, but more specifically engineered resilient systems. And so we didn't know anything about set-based design. So we okay, how do we learn? Of course, what we do, you go look at the literature. So we started with the literature review, and we were really looking at how does set-based design integrate with trade-off analysis in the literature, if any. And the big things we found was that, yes, set-based design was part of the literature before us, of course, but there was not a clear definition of what makes a set, as well as there wasn't a clear understanding of how to do a quantitative set-based design process. And so from that literature review, we started doing other things. And in tandem to this literature review, one of the things that we started working on was a demo, because if you want to do techniques, you got to have some type of tool to use to test them on, right? So Colin Small, this was started as his undergraduate thesis, but then it moved to his master's thesis. And so he worked on a UAV case study and implementing set-based design. This was all in Excel. And what he did was he used this idea of integrating models with set-based design. So we could show how you connect the design decisions all the way through the various models to value. And like I said, it was in Excel, and it actually became a very complex model. And you can't see that on this slide, but I think it's important. So in my next slide, I'm going to blow that up for you to see. But before we go on, what was very interesting about his project are the three things at the bottom. He found that you can incorporate uncertainty in set-based design. You see here, But what he did is, so we started this case study based off of another case study that another Department of Defense organization started. And so we took it, and Colin really expanded it, right? And so after he expanded it, he gave the model back and said, hey, could you use, so we didn't give the set-based design parts of it, just the model itself. Can you use your typical techniques to come up with as many designs that you would usually for your point designs to then carry forward to your decision makers to select which ones, right? And when they did this, the expert came back with 32 point designs, which is really good because a lot of times you see like 3 or 5, right? So they came back with the 32, which you can kind of see in the red, right? And we plotted them on the same trade space as our set-based design. And it blew our mind that our Pareto frontier was way above what the expert came up with. So that at first gave us this idea that, okay, there's something here that could really be helpful. Another interesting thing from Colin's work was that he looked at, okay, so his model contained some of the ilities like availability, survivability, and it was modeled as a mission chain within scoring some of the multiple objective decision analysis values in the model. And so what this perfect options idea came about was if we swung, or he swung, everything from, say, availability, survivability, do them one at a time, right? And so leave survivability at its nominal values, but swing availability from 0% to 100%, what's the effect on the trade space? And by doing that, he really saw how those ilities were affecting the overall trade space, which was interesting. Now, I told you this model was pretty complex, and this gives you an idea. We came up with this idea of trade-off analytics hierarchy, which if you're interested, we have a publication in a cozy publication that talks just about the trade-off analytics hierarchy. I'm happy to send information on that if you're interested, but it breaks down to the descriptive, prescriptive, and predictive analytics, right? And you can see that, he starts with 7 design parameters, and he's using probability management, which is SIPMAP. It's a Excel plugin for really helps with Monte Carlo simulation and some other things developed by Sam Savage to generate 100,000 designs for the space. And of course, there's other metrics there, but let's just focus on those for now. Those 100,000 designs based off of those 7 design parameters then trickle through all the models. When you look at the predictive models, from here, yes, there's 47 physics models, and really they're parametric physics equations, right? But when you're trickling all the designs and every calculation going through, the model is making 21.9 million calculations just on those physics parametric equations. And some of them also have, it shouldn't stay stochastic, it's really just a probabilistic parameter. But we're making 1.1 million value estimates as well as 100,000 cost estimates. And then when you get to the prescriptive side, you're getting to the end life cycle cost versus value. And of course, the value is a multiple objective decision analysis model. On the point side, we found that there were 2,576 feasible value points, right? And 97,424 infeasible points. And we also looked at that from a probabilistic point of view, but that shows you the complexity of everything that's trickling through this Excel model. And for the next project, which was actually part of my dissertation, I used Colin's model to really try to think through, okay, so Colin came up with this idea and came up with how we could do set-based design, but it wasn't really formalized, and how can we tweak it? And so my work looked at working with Colin's stuff and our team to formalize how can we do quantify set-based design, especially for early design decisions. And that's what we created. We created the set-based design implementation method. We formalized different methods to look at how do you identify sets. And that came from visually, so doing one factor at a time analysis and looking at it from a visual representation in a figure, right? We also used a design of experiment techniques like factor analysis, right? And then from there, once you have the sets identified, we started looking at methods to evaluate those sets for selection. And one of the things that we found to be most promising and useful was using dominance to help us with set evaluation and selection. Now, a very interesting part of this work was that we were curious, just like Colin was, on the original method, how to compare versus, say, an expert. Well, we took it to the next, and we really had the intention of, are we coming up with good design decisions? And so we used Excel, some of the Excel's built-in optimization techniques, which would be pretty standard to use in industry. We didn't use very complex outside of Excel that, from a research standpoint, that might be better. So we're trying to use what would be used in industry and would have easy access, that kind of thing. So we used some of the built-in Excel. And what we found is our trade space had over 100 points on the Pareto frontier that the optimization techniques did not find. And to us, we were just trying to use optimization to show that we found a good points, but to see that it performed better than the optimization techniques that we found was mind-blowing. We thought that was very encouraging, right? And so after we developed and were using this, we started thinking that, okay, this is really from the point of view of the analyst, right? But from a team perspective, it's really a social technical process. And the analyst is just one person doing this, but they're working with, the chief engineer, architects, as well as designers, various decision makers and holders. So what we did is we came up with a process that integrated this implementation process in it to be more holistic. And that team-based approach, what we found by integrating teams and other people, you can really get to better conversations to inform requirement development or analysis, as well as design decision analysis. And so from this, you can try to look at how does maybe one model or one decision type, right? How does that trickle affect the entire overall decision or design, right? And you could take it to them like, hey, the design space for design A option B isn't even feasible. So is it the model, or is it just because we need, maybe you have like in the UAV example, we actually had a design space with two engines, right? We had an electric engine and a traditional mechanical engine. And what we found is the electrical engines, like majority of the design space were infeasible just because of weight requirements and everything else on other models. And so you could take that back to the engine team and be like, hey, we either need another engine or you need to change this design for the electrical engine to make it more feasible. And so that gives you some ideas of the possibilities. Then from there, another student, Dr. Nick Shellcross, who was an Army officer, he finished his PhD in 2021. What he was looking at is, okay, how can we use what we've done with set-based design, but take it to the next level? So he performed another literature review, and what he found from a large gap analysis, that there was really an opportunity to integrate set-based design and program management. And since he was part of the team that helped develop that social technical process for set-based design, he expanded it to then change it to look at a program management point of view. And what was really interesting about his work is two of the pictures on here. And one was he came up with this idea. Of course, he's using multiple objective decision analysis, but he came up with this idea of using the traditional thought of entropy, which is a thermodynamics principle, right? To be able to evaluate different values. And so he uses that to help evaluate design decisions, right? And of course, he's using an iterative process to go from a large trade space to a smaller trade space. But the next thing that was very interesting is, so his model is in, it's not just Excel. So he took the UAV case study, and instead of doing it just in Excel, which is low resolution, he wanted to expand it from a program point of view to allow multiple resolution models. And to do that, he looked at what some industry partners and DoD partners were using, and he found that Model Center was one of the tools, right? And so he implemented the UAV model in Model Center, but then he changed the ability to do different resolution of models. So his end result used models from Excel to Java as well as Python, but still did it in an integrated environment. So you could still get the benefits of that integrated model that I talked about earlier. And by doing that, he came up with this idea of multi-objective value of information. And if you're not familiar with the value of information, it's basically, if you go back to that influence diagram, one of those probabilistic arrows, like if you flipped it for the probabilistic relationship, it would be basically saying you knew that one thing happened before it actually happened that originally would feed into this. And so think about it this way. If you could get greater value from doing a test or a market survey, how much would you be willing to spend to do that, right? And how much additional value would it bring? And so that's the kind of the idea of this value of information. And what he did from a multiple objective approach, and why he did it for the set-based design, was he was trying to help program managers know, okay, so we have all these models and simulations and all these other things and that's going on into the model, but what model or simulation do we need to increase the resolution to get more information? Where should we spend that time on? Because you can't spend it on everything. And some factors are not even worth spending the time on. And so that's where this value of information came in handy to help him be able to help program managers do that. So my next example is going to kind of shift courses from set-based design to show another way that we've used multiple objective decision analysis and other just decision analysis tools. And what it was working with stakeholder engagement. So we had a client who, it was a large DoD organization who wanted a way to look at how can they better engage their stakeholders and know who to engage. And so from our research, so we did several interviews, we did a literature review. From all that, we developed a best practice for stakeholder engagement. And we use that stakeholder engagement best practices to work with the client to come up with project categories, as well as how to integrate that best practice process that we found into their business development. And then we developed some Tableau dashboards as a prototype to show them how to show some of the information to be valuable. But in reality, the big thing we learned was that stakeholder engagement is really means, and the end is business development. And you can think about that from your own research groups that, when you're trying to get grants, that's the business development. Getting the money is the ends, right? But you have to talk with the right program officers and get them to know you and your work and, get your reputation out there so that the panel might be more familiar with what you're doing. And that's doing the means, right? So the engagement piece. And so stakeholder engagement is the means, but the ends is the business development, right? And where we use multiple objective decision analysis in this is helping us identify different decision frames for the project categories, as well as identifying, stakeholder engagement levels and power levels or authority levels. Now, another interesting project is on border sensor location. So we worked with the engineer. This is embarrassing. The engineer design. The U.S. Corps Army's, the Engineer Development Research Center, there we go, I can say it now, and Homeland Security about border protection. And so they were trying to figure out, if you have a section of the border, wherever that is, where do you place the sensors to get the best protection, basically. And so this was a project that started as an undergraduate project with Josh Jensen, as well as a student from Princeton who was working with him in the summer, and he just continued staying with our group, Joseph, that they did it as an undergraduate group. And then, of course, Josh continued as his master's thesis as well. So they came out with this system architecture to model it all. And really what makes this interesting from a decision analysis point of view, and the big thing is that all these pixels in these pictures you see, they were built using a MODA model, multiple objective decision analysis model, that takes 5 GIS attributes and it scores every single pixel. And then with all those pixels scored, they use a shortest path algorithm on the least amount of risk to develop potential routes. And then on top of that, they use optimization to determine optimal placement of sensors to maximize the probability of detection. And so we really think that's an interesting way to apply multiple objective decision analysis that you don't normally see in the literature or in industry. Another practice was looking at, or example was looking at reliability. And often reliability isn't incorporated early on, and it's typically not modeled. And so when you look at this influence diagram, you typically see the reliability later on with models and simulation. But we wanted to put, how can we get it earlier on in the design early life cycle process, right? And the key that we found was that, often reliability in the literature, it's modeled on the component level. So to be able to do it earlier on, you have to figure out another way to do it. And so what Tribari did for his master's thesis is he found that you can model reliability as functions and incorporate it through those functions, but then use technology readiness level to assess the reliability. So you can think about it this way: a lower technology readiness level would mean you would have a lower probability of reliability. And you can see that here. And so on the figure on the left down here, you can see like a TRL of 5, which is blue, right? Would mean that you have a lower reliability level and you actually have higher costs because of that, or potential costs, right? But you can also add uncertainty to the model and use Monte Carlo simulation to see how that could change, but it has the same pattern. And so we thought that was pretty interesting. Another example was applying decision analysis tools to asset management. And to kind of give you an idea of the assets that we're talking about, is the U.S. Corps of our Army of Engineers, they have 8 big areas of assets: energy management, or excuse me, emergency management, environmental stewardship, flood risk management, hydropower, navigation, recreation, water supply, and aquatic ecosystem restoration. And when we were looking at this, we found that they have about $259 billion of assets, only a budget of $6.4 billion per year. So it's very important that they prioritize the right assets and have a really good asset management process. And so what the student, and so the student was, I need to call out Brandon while you can see him, right? So what Brandon did, starting out as his undergraduate research and then into a master's thesis, is his work started out with looking at the literature and doing stakeholder interviews. That's usually how we start most of our work, right? But we worked with them to develop this idea of an asset management decision context, which is what you see here. And this took documents that define processes for all assets and then synthesizing them into this decision context. Then this helped us identify the needs and work packages. And so out of this model comes funded projects and priority activities. And where multiple objective decision analysis comes into play is that the line of sight model uses MODA that helps us go from the business line to objectives, to assets, to the metrics, to then be able to get to the priority activities and the funded projects. Now, on top of developing this, they needed a way to look at it. So what Brandon did was develop a dashboard, and he did use Power BI based off the client's need. And this is an example dashboard, and it's actually using recreation data for U.S. Corps of Engineers, which is actually published. So this is nothing that's classified or anything that you can get a lot of that data as open source. And when you look at it from a recreation point of view for the Corps of Engineers, what we found by this dashboard and the model that they basically get 48 million in funds, but they really need 250 million to operate. And what's also cool about this dashboard is you can click on these division data slicers, like by the directorate, like SWD stands for the Southwest Director or Directorate, right? And you could click on that, and then it would open up and look at it from the perspective of just that directorate. Another example of the dashboard actually looks at risk with some of the information. And our big surprise from this is that none of the red had funding, right? So you don't see any funding down here that's red. And so that means that there are no high risk, high reward projects being funded. And when you talk about portfolio management, you do want a more of a balanced portfolio that includes various risks and various rewards to be able to get the best long-term to work towards your long-term strategic goals. Because if you think about it this way, if you ignore some of those high risk, high rewards, what you could have is a catastrophic event like a failed dam, and that would be casualties like lives, right? And so that's a problem. And then the last example I'm going to give you is about single objective. So our team does use single objective. We actually use single and multiple objective. It really just depends on what's best for the client. How we teach our students is you start with single objective, and if you can't reduce all your objectives down to a single objective, then you use multiple objective decision analysis. And with this client, this was with a large transportation company. We created we did a literature review on best practices for cost models and in these areas, but then we created a in-depth cost analysis model that used risk analysis, scenario analysis, as well as sensitivity analysis to help them with FEMA disaster, as well as transporting military equipment. And with that being said, I talked about the system design and analytics laboratories vision, our team, our key research areas, some of the tools that we like to use, like integrated modeling and set-based design, and then some past projects. And with that, are there any questions?
Thank you, Eric. That was great. We will open the floor for any questions. Feel free to just either ask them or raise your hand and I can call on you, or feel free to put them in the chat.
Hey, Dr. Specking, I have a question for the set-based design work.
Sure.
So you, one of the slides said, it was kind of walking through the process and it said, identify the sets. And it makes sense to me if the axes are already known, this one. So the second one there. So it makes sense to me on how to cluster things if I already know the axes. So if I already know how to characterize the sets, but how do you come up with the way to characterize those sets? How do you come up with the axes?
Great question. So you could actually do this type of trade-off analysis among different design parameters or different performance indicators. So there's several different ways to do this. What we were looking at it was from an overall system performance point of view. And so what you're seeing is actually the affordability analysis. So it's using the life cycle cost as the x-axis and the multiple objective system performance as the y. And from how we modeled it, it is actually system performance for that value for this example. But really, you could do multiple parameters. It depends on how you wanted to look at it. You have flexibilities, but that goes back to your integrated model when you start looking at how you want to put everything together to trickle through. What are the things that you really care about, right? And for us, we wanted to get to this affordability. So that's what we knew our trade-off, overall trade-off analysis. But when I talk about that team, it might be more useful when I go to a design team about engines, right? To show them not only that affordability analysis and how their models affected that and their design parameters affected that piece, right? But I also might want to show them the perspective from their parameter versus some other parameters. So you're able to get some into very interesting subsetting of the data, but it's more about having the data there.
Thank you.
Sure.
Any other questions?
I was going to ask, my apologies if I missed it, but when you were mentioning the set theory and how you had to develop the sort of the quantitative version of it, I wasn't quite sure. I understood like what the set-based design had been previously. Like, if not quantitative, then how were the sets organized? Kind of
Great question. So when you originally looked at the literature and what you talked about, I believe is here, what we found is there were some who talked about and gave it lip service, and they would say how I would classify it as using traditional set theory notation, right? But they would just give it lip service. It wasn't a quantitative paper to talk about how they use set theory to quantify it, right? Others would just talk about the benefit of set-based design, like some of the early work that talked about what Toyota did. It talked about the benefits, but it really never talked about how you did it. Does that answer your question, David?
I think so. The earlier ones were more sort of
Qualitative in nature.
Okay. Okay. Yes, I think so.
Yeah. So when we do literature review, I like to classify or encourage students to classify papers as quantitative, qualitative, conceptual framework, or a mixture, right? And then that way, like if there's no numbers in it, it could be more theoretical, right? Or it could just be more qualitative, right? Now, if you're starting to see numbers and not just more theoretical math, right? You have that and some examples and other things. You're now getting to more of quantitative studies, right? And then others, like a conceptual framework, would be, oh, we have these very theoretical idea of how it could flow, and they put together something like this figure, right? That gives you a concept, but they don't really dive into it. And when we did that, that's how we saw more of it was qualitative than quantitative.
Gotcha. Thank you.
Sure. Other questions? This has been fun.
No other questions? Okay. Well, thank you again, Dr. Specking, for joining us. And we really appreciate it.
Yeah, I greatly appreciate the invitation. Hopefully you found it informative or at least interesting. I would love to hear more about what your team's doing in the future. And if y'all have any questions or would like to partner something in the future, we definitely are always looking for ways that we can partner to, help each other make things better. So
Awesome. Thank you so much.
Thank you so much for watching the latest installment in the Mesmer Research Group Guest Speaker Series. We really hope you enjoyed it. For more information about our research group or how to get involved, please check us out at uah.edu/MRG. We can also be found on LinkedIn, and don't forget to subscribe to our channel for more videos like this one.